All right, so picking up with number 33, they ask us what is the exact value of cotangent pi? So looking at our circle, if we go to pi, we can see the ordered pair here is -1, 0. All right, so from that ordered pair, we know that cosine is the x value and sine is the y value. So that would give us -1 over 0, which is undefined because remember, division by 0 is impossible. If instead this had been tangent, tangent would have been sine over cosine. I would have had 0 over -1. That would have been 0. So 0 divided by a number other than 0 is going to give me 0. So you should be able for me to ask you any value off of the circle or a coterminal of the circle, and you should be able to give me any one of the 6 trig functions at that value. So when we're talking about thinking of other ways the questions could be asked. Okay, so 34. We have the point 3, -4. And they asked me to find cosecant. Okay, so first off, I need to figure out what quadrant I'm in. Well, if x is positive and y is negative, then I know that I'm in the 4th quadrant. All right, so I also know if x is 3 and y is -4 that I can use Pythagorean theorem to find my radius because x squared plus y squared is equal to r squared. So if we put 3 in for x and -4 in for y, we'll get 9 plus 16 or 25 is equal to r squared. And then when we take the square root, we would get plus or minus 5. But remember, the radius always has to be positive, so it's going to be a positive 5. And you may have recognized the 3, 4, 5 triangle there and not had to use Pythagorean theorem to get your 5. That's great. Okay, so cosecant by definition is r over y, and that is on the top of your formula sheet. So if I take my r value, which was 5, over my y value, which was -4, then I'll get -5/4. And if I want to double check my sine, we figured out we were in the 4th quadrant. So all students take calculus, only cosine and its reciprocal secant should be positive there. So cosecant should be negative. All right, then for 35, very similar. Only this time, instead of telling me this is x and this is y or whatever, they've told me that this is cosine, and I know that cosine is x over r. That's also on the top of my formula sheet. So cosine means x is 3 and r is 7. So again, if I know 2 of the 3 values, I can use Pythagorean theorem to find my 3rd value. So when I do 9 squared plus y squared is equal to 49, now remember that your radius has to be your hypotenuse. So that's why we didn't do 3 squared plus 7 squared. We did 3 squared plus y squared is equal to 7 squared. The radius is the hypotenuse. So that's going to give me y squared is equal to 40. Take the square root of both sides and we'll have square root of 40. So square root of 40 would be the same thing as 4 times 10. So square root of 4 is 2, and then we would have 10 underneath. And again, this can be positive or negative. It's going to depend on the quadrant that we're in. All right, so to figure out the quadrant we're in, they told us that cosine is positive, because that's a positive 3/7, right? And then they also told me sine is positive. So the only place sine and cosine are both positive is in the 1st quadrant. So if I'm in the 1st quadrant, then I know my answer is going to be positive. Okay, so cotangent by definition is x over y, again, on the top of my formula sheet. And so x was 3 and y was 2 square roots of 10. So I'm not allowed to leave a radical in the denominator, so I'm going to rationalize. So multiply top and bottom by the square root of 10, and I'll have 3 square roots of 10 in my numerator, and then down here 2 times 10 or 20 in my denominator. All right, then for 36, they ask us to tell what quadrant we're in. So if tangent is greater than 0, it's positive. Cosine is less than 0, it's negative. The only place that tangent is positive and cosine is negative is going to be in the 3rd quadrant. All right, then it said find the exact value of sine 105 by using our sine addition formula. So on your formula sheet, if you look for your sine addition and subtraction formulas, and we'll see that sine addition is sine cosine plus cosine sine. So I'm going to put 60 in for my first value and 45 in for my second. So sine cosine plus cosine sine. And then I'm going to look on my circle and see that the sine at 60 is square root of 3 over 2. The cosine at 45 is square root of 2 over 2. Cosine at 60 is 1/2, and sine at 45 is square root of 2 over 2. So if we simplify, square root of 3 times square root of 2 is square root of 6, and 2 times 2 is 4. Then 1 times the square root of 2 is square root of 2, and 2 times 2 is 4. So since we have a common denominator, we can combine those two numerators over our common denominator. All right, then for the next one, they asked me to go the opposite way. So this time they give me the right-hand side, sine, cosine, plus cosine, sine, same one we just used a second ago. And so again, that's our sine addition formula. And you can see that that matches up, that we're going to put 100 in for A and 40 in for B. 100 in for A and 40 in for B. So over here, 100 in for A, 40 in for B gives me sine 140. Now, if you got here and you had a value like sine 60 or sine 120 or something that was on the circle, then we would want to go ahead and give the value for that. For 39, they asked me to find cosine 2u. So if you go over to your double angle formulas and you look at cosine double angle, there are 3 different formulas there. One of them only uses sine, one only uses cosine, and one uses both. So since they gave me the sine value, I'm just going to use the formula that only requires my sine. If I wanted to use one of the other formulas, all I would need to do is build a 3, 4, 5 triangle and pull my cosine of 3/5 off of that. Since it was in the second quadrant, it would be negative 3/5, but I'm going to use the formula that only requires the given information. So I'm going to put 4/5 in for sine, and then 4/5 squared is 16/25. 2 times that, remember that 2 is over 1. So we're going to do 2 times 16 is 32, but we're not going to do 2 times 25. So just 1 times 25. And then 32 over 32, I'm sorry, 25 over 25 minus 32 over 25 is negative 7 over 25. Now, you've got your graphing calculator. Put this whole thing in your graphing calculator and let it do this tedious computation for you. If you get to the end and it gives you a decimal, remember to just hit math, and the very first button there is change it to a fraction, and it'll switch it back for you. All right, then for number 40, we've got tangent half angle. So look at your half angle formulas. There are 2 of those. It doesn't matter which one you use. I picked 1 minus cosine over sine, but you could have used the other one. So for this one, I do need sine and cosine, and they only gave me sine, so I am going to need to build a triangle and find the cosine. So they told me I'm in the first quadrant. So I know that sine is opposite over hypotenuse. So I'm going to say, here's my angle. So opposite is 7. Hypotenuse is always opposite the right angle. So my hypotenuse is 25. And then I can do Pythagorean theorem to find my other side. Now we've done this same one already on our review. But if you did 24 squared plus 7 squared, that does equal 25 squared. So if I knew the 7 and the 25, I could say x squared plus y squared is equal to r squared. So 7 squared plus y squared is equal to 25 squared. And that way I could find the 24. Okay, so now that I've got my triangle, looking at this, I can say cosine is adjacent over hypotenuse. So cosine is going to be 24 over 25. So I'll come over here and put 24 over 25 in for cosine, and I'll put 7 over 25 in for sine. Now, I'm going to switch back over to my calculator for just a second, because putting this in using your fraction builder makes all the difference in the world. And so I don't want to have to do, I went through and worked it out by hand over here, but I don't want you to have to worry about tedious computation. So let me remind you of how we do this on our calculator. All right, so to begin with, I'm going to do alpha x to get that little fraction builder. Now, not all calculators have that little shortcut, but you should have alpha y equals. If you don't have alpha x, that first button would give you the same thing. So try alpha x. If you don't get this cute little fraction builder on there, then do alpha y equals, and You should, unless you have a very old calculator. All right, so then we're going to do 1 minus, and I'm going to get my little fraction builder again. So 24 over 25, and then in my denominator, do my little fraction builder again, and that's going to give me 7 over 25. All right, and if it had given me a decimal as my answer, I would just go to math, and this very first option up here changes it to a fraction, but it did give me that 1/7, that fraction value. Okay, so again, I worked it out by hand, but you definitely can let your calculator do those tedious computations for you, as we just saw. All right, then 41 says rewrite the product as a sum. So we're going to look at our product to sum formulas. And for our product to sum formulas, cosine sine is equal to this formula right here. All right, so if we match this up, u is going to be 4x and v is going to be 5x. So I'm going to come over here and put 4x in for u, 5x in for v, 4x in for u, 5x in for v. So that's going to give me sine 9x and then sine negative x. Now, remember that you cannot combine these in any way. So this literally is my answer. So none of those matched up here. Because this one was the closest one. It was a plus instead of a minus. All right, then for 42, write the sum as a product. So look at your sum to product formulas if you would, and we're looking for sine plus sine. So here's the sum to product formula, and you can see we're going to put 105 in for u and 75 in for v. So over here, 105 in for u, 75 in for v, 105 in for u, 75 in for v. So 105 and 75 is going to give me 180, and 105 minus 75 is going to give me 30. So now I have 180 over 2, which is 90, and 30 over 2, which is 15. So I can look on my circle and see the sine of 90 is 1. I don't know the cosine of 15. That's not on my circle. So I can leave that as my answer to cosine 15. All right, then for 43, they asked me to find all the solutions between 0 and 2 pi for where tangent is equal to the square root of 3. So I'm going to look on my circle, and because I love you so much, I added your tangent values on your circle. So they're not on mine, but right over here you've got square root of 3 over 3, 1, square root of 3. Then over here, negative square root of 3, 1, negative square root of 3 over 3. And then square root of 3 over 3, 1, square root of 3. And then over here, negative square root of 3, negative 1, negative square root of 3 over 3. All right, so you would be able to look at your circle with those tangent values on there and see that the only two places that you have a positive square root of 3 is at pi over 3 and 4 pi over 3. All right, then for 44, still following those same directions of solving between 0 and 2 pi. All right, so I'm going to go through and factor this. So 2 cosine squared could only be 2 cosine times cosine. And then 1 could only be 1 times 1. So since this is minus, one side's going to have to be plus and one side's going to have to be minus. So just a little bit of trial and error. I could try plus minus and see if that worked. And if it didn't, try minus plus. But you can see here 2 cosine times cosine is 2 cosine squared. 2 cosine times negative 1 is a negative 2 cosine. 1 times cosine is 1 cosine. So when I put negative 2 cosine and positive 1 cosine together, I get negative 1 cosine. And then positive 1 times negative 1 would be negative 1. So now that I have it factored, I can set each of those factors equal to 0. So here I'm going to add 1 to both sides and then divide by 2. And then here I'm going to add 1 to both sides. So then I'm looking on my circle to see where is cosine negative 1/2. All right, so cosine's the x value, remember. So right here at 2 pi over 3, and then down here at 4 pi over 3. All right, then we also want to know where our cosine value is equal to positive 1. So So cosine is positive 1 right here at 0. I do not need to say 0 and 2 pi. That's two different names for the same thing. Up here, you wouldn't say pi over 6 and then add 2 pi to get a coterminal for it and also say 13 pi over 6. So you don't need to say 0 and 2 pi. 0 is perfectly fine. You'll notice that in the directions, it is equal to 0, but